All right, you will notice that this slide already looks a little different than the ones you've ever seen me do before because it has two sections in one. Okay, so here's the way that I teach this section. Dr. Marsh did this before me, and I totally agree with her, is that really sections 1 and sections 2 is one big giant section that they have arbitrarily decided to divide in a weird way. Okay? So it doesn't make any sense to separate our discussion of the two sections. So I will teach all of it together, but what that means is it's going to take at least 3 days to teach it, okay? Maybe a little bit longer. And it also means that if you flip to the very back, what do you see? Lots of homework. So I strongly encourage you not to wait until we're completely done with this section to start working on some of it on your own. Skip the pieces that you have trouble with and move on to something else. That's fine. But I strongly encourage you not to actually wait until next Friday and try to get it done in the weekend. It's probably a bad idea kind of thing. Okay? All right, so let's take a look at some of the stuff in section 12.1/12.2. These are congruences through constructions. So we talked about the word congruent before. Congruent are two objects that have the same size and shape. Similar objects are objects that have the same shape, but not necessarily the same size. Now, by definition, two objects that are congruent are automatically similar, because similar is just a looser description. Two objects that are congruent are automatically similar. But just because two objects are similar would not, of course, mean they have to be congruent. All right, and for whatever reason it's up here. This shape, the symbol for congruent, we did that one before, looked like, I think we did that, didn't we? Congruent looked like that. Okay, so this is our symbol for congruent. And then our symbol for similar looks like this. It's just one single tilde. Okay, so this one is congruent, and this one is similar. All right, so we're going to do a picture and talk about some shapes within the picture that meet these criterion. You've probably all seen a picture like this before, and there's always that fun question, and it's usually more complicated than this when it says something like, how many triangles are in the picture? Y'all know what I'm talking about, right? And you have to count the little triangles and the big triangle, and there's usually even like a medium-sized triangle going on. You have to count all these different triangles. Well, the only way that those kinds of pictures, well, not the only way, I suppose, but the way that they're usually made is they're made like this, where all the shapes have things in common. They're all actually similar. Their shape is the same, but their sizes may not be. So if you take a look, the four small triangles inside are all congruent to each other because they're all the same shape and size. And you can kind of tell that because they've marked it along the edges. There's S's through here, right? Everything has S's on it. They're all the same length on the sides. And so all of them on the inside are congruent. And because they're all congruent to one another, they're all equilateral triangles as well, right? 3 congruents on the sides makes it equilateral. Okay. But each of the small triangles is also similar to the big triangle because they're the same shape, but they're actually different sizes, and that's okay. Same shape, different sizes means that they're all similar to the big triangle. So if you take a look, and we'll use the example of the bottom one. On the bottom, this shape right here has side lengths that are all S, correct? What do you know about the bigger triangle? What are its side lengths? They're all double that. They are all 2S. So they're all twice as large. And that's what it means to have the same shape, but it has some sort of a multiplication factor that you can enlarge it or shrink it. And we'll talk lots more in different sections even about this idea of enlarging and shrinking, but you could do it all the time. If you've ever used a copier and you've blown something up, if you've ever had a picture taken from a small size to a larger size, or vice versa, if you've ever used anything on a picture creating program like Shutterfly, or what are some of the other ones, MixPix or something like that, there's different ones online. They're all using this idea. They're creating a similar object but a different size. Our projector overhead does the same thing, right? It's inside there, it's this tiny little picture, but outside on our screen it's much larger. my picture here and the screen you're looking at are similar, correct? But they're not the same size, but the same shape, they're okay. All right, so we are going to take a look next at doing some constructions. Now, as we're doing these constructions, you guys need a protractor, not a protractor, but you need a straight edge and you need a compass. So let's talk about how we use a straight edge and a compass. If you have one with you, fantastic. If you don't, come get one. So these are straight edges. They're also protractors, but we're going to use a straight edge protractor. And compasses. Okay, so grab a compass and grab a straight edge, or a protractor is what I have. If you want to use your ID card, that'll work. I'm not even sure how much we need of all of it today, but we'll use what we've got. All right, so once upon a time, the math department had money enough to buy these fantastic compasses, and these are really good compasses, okay? They aren't super expensive, but when I say they're really good, is they just work very, very well. So you'll notice on the inside it has the wheel, and that makes it extend out, it makes it extend in. Each of the prongs has little rolly pieces, right, where you can extend out the pencil piece or push it further in, and then the other side has the pointed metal piece that will hold your and it's very sharp. I mean, it's not going to hurt you, but it will hold it very securely on your piece of paper, okay? So these compasses work really well. And we are going to take a look at how we're going to use these to construct different objects. So our goal when we do constructions is we're not measuring anything. Okay, so you will never use like the part on your protractor that actually has the units on it. I'm not going to say we're going to draw something 1 inch long. That's not going to happen. It's always going to be done with a compass and a straight edge. Everybody good so far? All right, here's the next thing you should know. I have a really cool program on my iPad, but I don't have any way to record the program while I'm using it, okay? So every time I stop one of these videos, it's going to be to get into the other program called Sketchpad, and I'm going to use the Sketchpad program, and when I'm using that, there's no video that shows me using it. However, there are links inside of our Moodle Room site to other people on YouTube doing examples of these particular constructions. So if you want to see a construction again, you can. You just don't get to hear my beautiful voice doing it. You'll get to hear somebody else's. You might even see their hand, because some of them are actually like pictures of people doing it physically, not just on an electronic device. Okay? All right, so we're going to start with a circle. We've already talked a little bit about circles, but a circle is a set of all points in a plane that are the same distance, called the radius, from a single point, called the center. And we are going to use a compass and a straight edge to construct a circle. Are you guys ready?
Yes.
All right. All right, our second construction that we're going to do, and we'll do it super fast and quick, is constructing congruent segments. There are 3 basic ways to construct congruent segments. You could trace them, right? Imagine putting a piece of paper on top of another paper, straight edge, you could trace a segment, correct? Sure. You could measure it, right? That's possible too. You can't really measure a circle very well, so that sort of falls flat. Even sketching through trace paper on a circle, that's pretty tough. But you can do it for a segment. But the way we're going to talk about is using, again, a straight edge and compass. All right? So, again, I would like for you to use that same segment you have above with your approach or your compass the right width. Okay? You already know how to do it. Your compass should already be that way unless you've manipulated it since we left it. And I would like for you to take that, just set that compass aside for a second. Take your straight edge and draw a line segment of arbitrary length. Okay, longer than that you need, but arbitrary length.